Hey, Geometry. Here to talk to you today about the Pythagorean Theorem. First of all, we're going to talk about the parts of a right triangle. On this right triangle I'm going to label one side A, one side B, and one side C. A and B are known as low legs, and you already know that C is known as the hypotenuse. The Pythagorean theorem says that these sides are related by a formula that goes a squared plus b squared equals c squared. Remember that a and b are the legs because they make the right angle. And C is the hypotenuse, which is across from the right angle. Now we'll do a couple examples. Example 1, solve for x. Here's the picture that we're going to work with. So 5 is going to be A, 10 is going to be B, and X is going to serve as C. And I'm going to set up my Pythagorean theorem. And now I'm going to substitute. A is 5, B is 10, and C is our variable x. Now I'm going to simplify. 5 squared is 25, 10 squared is 100. Now I'm going to add 25 plus 100. To get 125. And now I square root both sides to get rid of the exponent. But I'm not done because I want to simplify square root 125 before all is said and done. I can break this down to 5 and 25, and I can break that down to 5 and 5. I've got a pair of 5s, so a 5 can come out. I've got a single 5, that's got to stay in. So, back over here, I'm going to leave my answer as 5 square root 5. The second example is going to have a picture like this. X on that side, 4 on that side, and 11 on that side. So, this time, 4 can serve as A, X can serve as B, and 11 will serve as C, the hypotenuse. There's the Pythagorean theorem. And now I substitute. A is 4, B is x, and C is 11. 4 squared is really 16. 11 squared is really 121. Here I need to subtract 16 from both sides. So x squared equals 105. Then I square root to get rid of that exponent. X equals square root 105. But before all is said and done, I'm going to see if I can simplify square root 105. 5 and 21, 3 and 7. You can see here, I don't have any pairs to circle, so there's no way that I can simplify this. I will just have to leave it as square root 105. The next section is going to be called Pythagorean Triples. A Pythagorean triple is a combination of 3 whole numbers that fit the Pythagorean theorem. Some examples would be 3, 4, 5. Because 3 squared plus 4 squared equals 5 squared. Also, any multiple of 3, 4, 5 will work. An example would be 6, 8, 10. Another example of a Pythagorean triple could be 5, 12, 13. Because 5 squared plus 12 squared equals 13 squared. And just like 3, 4, 5, any multiple of 5, 12, 13 also works. Example 10, 24, 26. The last section of these notes is going to be called Converse of the Pythagorean Theorem. A squared plus b squared question mark c squared can tell you if a triangle is right, acute, or obtuse. Remember, a right triangle looks like that, an acute triangle looks like that, and an obtuse triangle looks like that. We know that for a right triangle, a squared plus b squared equals c squared. That's the whole idea of the Pythagorean theorem. For an acute triangle, a squared plus b squared is greater than c squared. And for an obtuse triangle, a squared plus b squared is less than c squared. So let's do an example. Given sides 4, 4, and 5, find out if the triangle is right, acute, or obtuse. First thing I'm going to do is set up the converse of the Pythagorean theorem. 4 is going to serve as A. The other 4 is going to serve as B. And 5 is going to serve as C. Now I'm going to substitute. A is 4. B is 4. And C is 5. 4 squared is really 16. 5 squared is really 25. 16 plus 16 makes 32. It's plain to see that 32 is not equal to 25. Instead, 32 is greater than 25. And because we said greater than, that means it's an acute triangle, which will look like this.